So this video is a review of multiplying when we have multi-digit factors, and this goes along with the multiplying with one-digit factors. That is another review video lesson. And so as with that lesson, the two most important things that we can remember about multiplying are there's no need to align place values. Now, if we have only integers, the place values will be aligned by default. If we have decimals, they won't necessarily be, but we don't need them to be because we're using multiplication. And that carrying has a slightly different meaning when you're multiplying. But since we are using multi-digit multiplication now, that is, neither of the factors has one digit. They both have 2, 3, 4, etc. Is that we need to remember place value. In fact, if we don't remember place value while we are working with multi-digit multiplication, we are not going to end up with the correct answer. So let's take a look at a few examples, and then I'll give you a few practice problems for the end there. So let's take a look at a fairly simple one, 328 times 12. Now, as we mentioned, we don't have to align the place values, but in this case, they will be because they will have the one's place value be at the right for both of them. And now we start with the 2 in terms of the multiplication. 2 times 8 is 16. 2 times 2 is 1, or 2 times 2 is 4, plus 1 is 5. And 3 times 2 is 6. So that's what we get when we multiply by the 2. But now we have to deal with the 1. And remember that this 1 is not actually a 1, it is a 10. Because it is in the 10's place value. So when we multiply the 328 by the 1, we have to adjust for the fact that it's a 10, and so we put a placeholder 0 here. And now we have 8, 2, and 3. And we go through with our standard addition to make sure that we end up with the correct sum, which is 3,936. So 328 times 12 is 3,936. Let's take a look at a few more examples that go through that same idea. 97 times 30, we'll multiply 97 times 30. Now there are two ways we can approach this one. First, we could go through with the zeros for the ones place and multiply 7 times 0 is 0, 0 times 9 is 0. Then we have our second digit, which is the 3. That is actually a 30. So we had a placeholder 0. 3 times 7 is 21, plus 2. For the next one, 3 times 9 is 27. 27 plus 2 is 29. And so we have 2,910. But because we have a 0 in this place value for the ones, we could almost have just skipped that entire set there and just gone straight to the 3. And in general, we can do that. I prefer, for the next problem, to always have the smaller number of digits in the factors be on the bottom so that we can go through the least amount of multiplication steps possible, partially because it saves time and also because it minimizes the chance for a mistake to happen. 4 times 101 is 404. Remember that this 3 is actually a 30, so we add our placeholder 0, multiply across and get 303. Then we add them together, we get 3,434. And that is our product. Two more examples and then some practice problems. Now we have 782 times 53. 2 times 3 is 6. 3 times 8 is 24. With the extra 2 here, 3 times 7 is 21, plus 2 is 23. Now moving on to the 50, which, as we said, that 5 actually means a 50. So we have a placeholder 0. 5 times 2 is 10. And now we carry, and as we can see, we could potentially have a scenario where we're not entirely sure which carrying numbers are which. In this example, I've used different colors to make sure that we don't get confused, but you can always cross them out or erase the original carrying when you get to the second part. 5 times 8 is 40, plus 1 is 41. And now 5 times 7 is 35, plus 4 is 39. 6, 4, 4, 1, 4. 41,446 is our product. And our last example before we go to the problems that you'll work on, I'll just write it here. Again, we have a 0 in the ones place. This time I'm just going to skip it and say, well, we know everything's going to be a 0. It won't affect our addition. But that 2 still means 20, so we have to put a placeholder 0 there. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2, and 2 times 2 is 4. Now our 1 is actually a 100. So instead of adding just one placeholder 0, we're going to add 2 placeholder 0s. And then, of course, 1 times anything is just itself. 0, 0, 0, carry the 1. 5, 5, 2. we get 255,000. So go ahead, pause the video, work through these 2 example problems, and then come back when you're ready to go through the answers and go to the final 2 practice problems at the end of the video. So for 121 times 121, this is a fairly simple one. Not a whole lot of carrying. In fact, no carrying. 1 times 121 is 121. That 2 is a 20. So we add our placeholder zeros. We multiply those through and get 242. That 1 is actually a 100. So we add 2 placeholder zeros. We get 1, 2, 1. 1, 4, 6, 4, 1. When we add up, so we get 14,641. Our second multiplication here is 782 times 1008. I'm going to leave the 1008 on the bottom here because it has only 2 digits to multiply for. Now we'll see how the zeros go in just a second. But going with the 8, 2 times 8 is 16. Add 1, 8 times 8 is 64, plus 1 is 65. Carry the 6, 8 times 7 is 56, plus 6 is 62. Now, the next digit that we have in the tens place is a 0, so we could add our placeholder 0, but everything else becomes a 0. The next digit that we have, which is also a 0, is in the hundreds place, so we add our placeholder digits, but everything there becomes a 0, so we really could just skip these 2 if we wanted to. Then we get to the 1, which actually represents 1,000 and not 1, so we have to add 3 placeholder zeros. We get to 8, 7, adding down the columns. In each column, we get 788,256. Finally, the last 2 problems, go ahead and pause the video, work on these, and come back when you are ready to go through their answers. So now we have 7,253 times 47. Now 7 times 3 is 21. Carry the 2. 7 times 5 is 35, plus 2 is 37. Carry the 3. 7 times 2 is 14, plus 3 is 17. Carry the 1. 7 times 7 is 49, so 49 plus 1 is 50. I'm going to leave these carrying digits here so we can see how we could do it otherwise. Different color, add our placeholder 0 because the 4 is actually a 40. 4 times 3 is 12. Now we're going to carry the 1. 4 times 5 is 20, plus 1 is 21. Carry the 2. 4 times 2 is 8, plus 2 is 10. Carry the 1. 4 times 7 is 28, plus 1 is 29. Add as we normally would. 1, 9, 8, 0, 4. Carry the 1, 3. Gives you 340,891. And finally, 9,009 times 909. 9 times 9 is 81. Carry the 8. 9 times 0 is 0, plus 8 is 8. 0 and an 81. I'm going to skip this next one with a 0 because everything will be a 0, but I'm going to move on to the 9 here, which actually represents a 900, and add our 2 placeholder zeros. And then 9 times 9,009 is exactly what we had gotten before, so we can just copy that because it's the same. 1, 8, 1, 9, 8, 1, 8 is what we end up with when we add all of this together. So our final answer is 8,189,181. As a brief reminder, remember that we do not have to align the place values for multiplication. We just have to have the smallest place value all the way to the right for both of our factors when we're using multiplication. If we have integers, they'll be aligned by default, but if we have decimals, we won't necessarily be aligned. We might be, but we won't necessarily. Carrying has a new meaning, and we have to remember that this place value, each of these digits represents either a 10 or a 100 or 1,000 or a 10,000 or something like that beyond the first. So we have to add the appropriate number of placeholder zeros to make sure that we're actually multiplying by, in this last example, 900 with 2 zeros rather than just 9.